This is the backside of our kite properties worksheet. We're going to do a few of these together. We may do 6 through 8 in this video. We're going to find the perimeter of this kite. And notice how they named this kite. Kite, K-I-T-E. Okay, so by definition, kites have those adjacent sides congruent and these adjacent sides congruent. But you don't have any opposite sides congruent. So that's going to be 7, that's going to be 18. I think maybe we'll do number 8 next. It's telling us that these are kites. So you know this and you know this. Now remember, these are isosceles triangles. That's going to give you right angles here because these diagonals are perpendicular. Whatever you have here is going to match there. And then 90 minus 18 is 72 for these angles. This triangle is congruent to that triangle. Same thing happens down here. So that's going to be a 29-degree angle. This will be a 61-degree angle. This triangle matches that triangle. Number 7. Now we have some variables in here. Makes it look a little bit tougher, but it's really not that bad. It's really the same thing. If you want to, just pretend the variable's not there for a second. That's going to be a 41-degree angle. I think we already used this number before. So that's a 49-degree angle. So what's the measure of this angle here? It's going to be 49 degrees also. So if you just forget about the variable for a second and realize that that's a 49-degree angle, now you know that 4 times a number minus 3 must be 49. And then you can solve for x. We got to find y also. It's just a missing angle. If that angle's 59, we know this angle's 59. What's the value of y? That's going to be whatever's left over to get you to 90. 59 and 31 add up to 90. And that's all you do on those. That actually didn't take too long. We might just keep moving here. If the perimeter of this kite, ABCD, is 86 feet, find x and y. So they're telling you it's a kite. So if that's 3y, so is that. If that's 2y, is it a plus? It looks like a minus. I think it's 2y minus 2. Kind of a big deal, so I'm hoping I'm right there. These 4 things must add up to 86. So 3y and 3y, 2y minus 2 plus 2y minus 2. We'll just write it all out like that to start with. That gives you 86. Now we're going to combine our like terms. That's 6y, 8y, 10y, minus 4 equals 86. So if you add 4 to both sides, you're going to get 10y equals 90. So 1y equals 9. So we know what y is. We just need to figure out what x is at this point. Now, these are the same because this segment gets bisected by that one. Remember, this is a perpendicular bisector of this segment. So 5x minus 15 equals 2x plus 3. I think that's what that says. I know that's really, really tough to see. But we're going to subtract 2x from both sides. And we're going to add 15 to both sides. That looks pretty good. Number 10 is about a rhombus. Oh, I'm sorry. This is a trapezoid. Number 11 is about a rhombus. So they're telling you this is a trapezoid. They're telling you what's parallel. Segment RS is parallel to segment TU. So we'll take a second and make those marks. They're also telling you X is the midpoint of segment RT. V is the midpoint of segment SU. So we know this is happening. So that's a midsegment. R to S is 30. X to V is 44. How long is the other base? Well, there's a difference of 14 here. So there's got to be a difference of 14 here. So we'll say this is 58. There's the rhombus. All right, so we have diagonals. A to D is 10. What's the length of this diagonal? Oh, no, they're telling you. The length of this diagonal is 12. Well, we know that each piece here is 6 then. What's the length of segment DB? Well, this one's a pretty easy one if you remember your triples. Remember, the diagonals of a rhombus are perpendicular. We know those are the same. So you have this little right triangle. 6, something, and 10. 6, 8, 10. Makes a triple. So if that's 8, that's 8. The whole thing is 16.